Constant of proportionality. Is there anything in there, in the constant of proportionality, that makes your brain think, oh, I might have an inkling? Gabe, what?
Is the
Thank you.
proportionality.
What does proportionality mean?
How much there is of each thing.
Okay, so a proportion is a, what's a word for it? What does it look like? What does a proportion look like? It's a fraction, right? And a fraction is also known as a, it starts with an R, ratio. So the constant of proportionality is the ratio. And you just told me that ratio is a fancy word for fraction. That the constant of proportionality is a ratio. It's a fraction. So we're still working with proportionals. Proportions, fractions. But, ladies and gentlemen, we're now talking about graphs. And what are graphs made up of? What makes a graph a graph?
Grid lines.
Okay, grid lines.
Y-axis, x-axis.
A y-axis and an x-axis. So it's a ratio of y value to x value. So we're still going to make fractions. We're still going to take two values and put them in a fraction. But what fraction goes on top, or what number goes on top? The y value. And what goes on bottom? The x value. And that's the way that it is. Don't mix it up, because if you mix it up, it's wrong. Because the y value, ladies and gentlemen, is your up and down number, right? And your x value is your side-to-side number. In this case, constant means what? What does it mean if it's constant? It stays the same. Can you tell me what's constant with 1/2? What's constant to 1/2? What's constant, Morgan? Give me a constant to 1/2. What is 1/2 constant to? The same as? 5/10. But they look different, don't they?
Yeah.
But are they constant? One's simplified and one's not. So, ladies and gentlemen, what we have to get used to is that this constant of proportionality, this change that we're talking about, it has its own special letter, and it's represented by the letter K. And we write variables in cursive, for the most part. You can write it in manuscript, that's fine, but know that this is the letter K. And if K is the constant of proportionality, it's the y value over the x value. It's the y value over the x value. So it can be a fraction. Duh. 1/2. What else could it be, do you think? What do you think, Kaden?
Ratio.
A ratio, which is a fraction. What are specific ratios? Or rates. What's a specific type of rate? Stephanie? Oh, Stephanie, that's your sister's name. Lillian? A unit rate. And what makes a unit rate special? It can be a fraction. 1/2. It can be a unit rate. BB, what's a unit rate? What makes it special?
It's a number over 1.
It's a number over 1. And what is a number over 1? What's 10 over 1 the same as? 10. Or it can be an integer, right? Which is the number 10. I-N-T-E-G-E-R. That was hard for me to spell. It can be a fraction, 1 over 2. It can be a unit rate, 10 over 1. Or it can be an integer, just the number 10 or -5, right? Here's the deal. They also want you to know that it can be a decimal, and I say no, it can't. And that's because I'm selfish. That's because when I get you as an algebra student next year, I don't want you to use decimals. I'm selfish. If we just say no decimals in pre-algebra, it makes our algebra life a lot easier. So here's my deal to you, ladies and gentlemen. What if they say that it's 0.6? That's a decimal, but I tell you it's not really. They may tell you in this lesson, in this whole unit, they may say your rate of change, your constant of proportionality, is 0.6. And you're going to say, no, it's not 0.6. Don't be ridiculous. Olivia, what is it? 6/10. And that's okay. What else is it instead of 6/10? What else is it instead of 6/10? Lillian? 3/5. They're all the same, right? Which one is a no-no? Isabella, which one's a no-no? The decimal. Which one's the best? Which one's the best, Riley? 3/5. All right, so let's practice a little bit. Let's go down to from a table. And again, I'm going to kind of fold that back so you can see everything. You can unflap it all the way. John, you need to sit up. Thank you. All right, here we go. Make a ratio. So when we have a table, we're going to make a ratio. And look up here. What was our ratio of? It's a ratio of what? Y value to X value. So make a ratio of Y to X for all ordered pairs. Make a ratio of Y to X for all ordered pairs. And it's got to be Y to X. We're making proportions, we're making fractions, we're making a rate of change is what it's called. So here we go, are you ready? From 0 to 3, what happens? Plus 3. Good. From 0 to 1, what happens? Plus 1, right? So what's my ratio? 3 over 1. Y over X. Let's do the next one. From 3 to 6, what happens? Plus 3. And from 1 to 2, what happens? Plus 1. So what's my ratio? What? 3 over 1. If you went from the first one to the second one, it'd be 6 over 2, which is the same as 3 over 1. Let's do the next one. From 3 to 9. Or from 6 to 9, sorry. Plus 3. From 2 to 3. Plus 1. So what's my ratio? And last but not least, from 9 to 12, what do you get? Plus 3. And from 3 to 4, what do you get? So what's my constant of proportionality? What's my rate of change? 3 over 1. Sounds pretty good, right? So let's say, are all the ratios the same? Let's skip the exception for now. Are all the ratios the same?
Yes.
Yeah, 3 over 1, 3 over 1, 3 over 1. So what do you think this is? They're all the same. It's a constant ratio. It's proportional. It worked. So is this proportional? Is it prop or no prop? It's prop. It's proportional. And what's the rate of change? What's the K? 3 over 1. Let's try another one. Let's do all the y's at once and then all the x's at once. Maybe that'll go faster. Right? Let's see. From 1 to 3, what happens? Plus 2. From 3 to 5, what happened? From 5 to 7? 7 to 9. All right, let's go to the x's. 0 to 1, plus 1. 1 to 2, plus 1. 1 to 3, plus 1. 3 to 4. What's my rate of change? Is it proportional or not proportional? It's prop. Proportional. Why? Because it's 2 over 1. 2 over 1. 2 over 1. 2 over 1 every time. All right, let's try this one. Ooh, negatives. Yuck, right? We can do it. From -3 to +6. Plus 9. From 6 to 12. Plus 6. From 12 to 18. Plus 6. From 18 to 24. Plus 6. Let's try the x side. -2 to +4. Plus 6. From 4 to 8. Plus 4. From 8 to 12. Plus 4. From 12 to 16. What do you think? Proportional, prop, or no prop? I hear a little bit of mixture. All right, well, let's talk about it, right? What's the first proportion? 9 over 6. What's the next one? 6 over 4. Are those proportional? What can 9 over 6 be simplified to? 3 over 2. What can 6 over 4 be simplified to? Are they proportional? So what's my final answer? Could you put 9 over 6? It's okay. Could you put 6 over 4? It's okay. But what's the best one? 3 over 2. So just because you started doing this and you're like, wait a second, Mrs. Long, I could have stopped a long time ago. 9, 6, 6, 6. That 9's opposite, right? And 6, 4, 4, 4. That doesn't match. There's a weirdo in the group, right? But you can't, because maybe they really are proportionate. All right, let's try one more. I need a different color though. All right, I will. All right, here we go. From -2 to 0. +2. From 0 to 2. +2. From 2 to 4. And from 4 to 9. Now, I could say, should I stop and be like, uh-oh, there's a weirdo in the group, or do I have to keep going? I need to keep going, right? Because there was a weirdo in this group and it worked out. -1 to 0. +1. 0 to 1. 1 to 2. 2 to 3. What's my first proportional change? 2 over 1. Well, then what? 2 over 1, then 2 over 1, then 5 over 1. Are they equal? If I look, 2 over 1 and 5 over 1, they are not. So is this proportional or not proportional? So can you answer what's the constant rate of change? Is there one?
No.
There is none. So let's go back up here and fill this in. All the ratios are the same. It's proportional. Blank ratios, not proportional. What should we put? Different ratios. And K equals, what number did we put down here for K? Give me a formula. How do we figure these out? The y over the x. And it's in what form? Simplest. S-I-M-P-L. Got it. Simplest form.